and see what happens. Did I send you an email about reading the pages for this section? Oh, man. Well, my mistake. Sorry about that. Maybe it'll make sense to you when we walk through it. But if you want to reach back and read the pages real fast, that might help. It says it's ready to connect. Why isn't it connecting? The topic is on page 213, exercise 4.4. Well, what's going on? There we are. Good. Page 213, exercise 4.4. In problems 1 through 6, perform the indicated additions. Does everyone know that decimal 1 is binary 1, and decimal 2 is binary 1, 0, and decimal 3 is binary 1, 1, and decimal 4 is binary 1, 1, 0? You say, why is that? Well, let's go over at the top and see if we can put it. Here's binary is base 2, so here's 2 to the 0, 2 to the 1, 2 to the 2, and that would be far enough. So this is the 1's place, the 2's place, and 2 squared is the 4's place. So 4 would be 1, 4, no 2's, no 1's. 3 would be 1, 2, and 1, 1. And 2 would be 1, 2, and no 1's, and 1 would just be 1 over there. You follow how that works? So you might want to make a little chart like this on the left or like this across the top, so you can keep this stuff in front of you won't have it in your head necessarily, but you keep it close to you so you can glance at it and think about it. So let's turn this on to red and let's add these two numbers. It says add. So what's 1 plus 1 in your head? What's 1 plus 1? 2. How do I say 2 in binary? 1, 0. A 0 and carry the 1. Everybody follow that? Because 2 has 2 places. What's 1 and 1? 2. How do I say 2 in binary? Put down the 0 and carry the 1. Everybody follow that? Now, what's 1 plus 1 plus 1? 3. How do I say 3 in binary? 1, 1. So there's the answer. What do you think? This is not going to be that complicated, is it? What number is 1 plus 1? What is 111 in binary? What would that be in decimal? A 4, a 2, and a 1 would be what? 7, is that right? A 4, a 2, and a 1 would be 7. What's 1, 0, 1? 4 and 1 would be 5. What's 7 and 5 added together? 12. So here's the 1's place, here's the 2's place, here's the 4's place, and here's the 8's place. So you have 1 8 and 1 4 and no 2's and no 1's. Everybody follow? 8 and 4 adds up to 12. Just helping you kind of connect what we're doing. Now you don't have to do this stuff I'm doing in red. I'm just helping you connect what we're doing to what you already know in terms of your own mathematical reference point. So let's do problem 4. Any questions about problem 2? Let's do problem 4. What's 1 plus 1? And how do I say 2 in binary? 0 and carry the 1. What's 1 and 1 and 1? 3. How do I say 3 in binary? Put down a 1 and carry a 1. What's 1 and 1? 2. How do I say 2 in binary? Put down a 0 and carry a 1. What's 1 and 1 and 1? 3. How do I say 3 in binary? 1 1. There you go. 1 1 0 1 0 on base 2. That's all there is to it. Let's do number 6. What's 1 and 1? 2. So I put down a 0 and carry the 1. What's 1 and 1 and 1? So I put down a 1 and carry the 1. What's 1 and 1 and 1 and 1? 4. How do I say 4? So I have a 0, and a 1 out here. Everybody follow that? In the base 2. Okay. So now you know how to do addition, right? So now let's learn some subtraction. Can I subtract 1 from nothing? Were some of you taught, then subtract nothing from 1 and put down 1 for an answer? I have people who say, yeah, I always taught when you do subtraction, subtract the smallest from the largest. No, you subtract the bottom number from the top number. But there are no 1's here. How can I take 1 1 from no 1's? Oh, that's easy. I have 2's here, right? So I mark this out and have 2 1's over here. See where this 2 becomes 2 1's when I move it over? Like borrowing in the base 10 system, except we're borrowing in base 2, so we're always borrowing 2. So now I have 2 1's. I subtract 1 1. What's left? 1 1. Now this became a 0 because I borrowed it. So I come over here and borrow this one. And now I have 2 of these. You follow me? I borrowed this one. At 1 4 is equivalent to 2 2's. So 2 2's minus 1 2 is 1 2. And since I borrowed that, there's nothing else to bring down. So the answer is 1 1 in the base 2. You don't like subtraction. Well, if you recall when you learned decimal subtraction, you didn't like that either. So that's just life. Number 10. Subtract this from this top number. What's 1 minus 1? You go, I'm not sure. Okay. I can understand you being apprehensive. It's new stuff. 1 minus 1 would be 0. What's 0 minus 1? I can't do that. This becomes 0 and this becomes 2. See why I put a 2 up there? Because I have 2 of this place. And 2 of these minus 1 of these would leave what? 1. I had 0 here, so I marked this one out and put 2 here. And 2 of these minus 1 of these would leave 1.
Wait, wouldn't that be 2 2s? Because that's what we did in the other one.
I had 2 2s, I had 0, so I borrowed here, and that gave me 2 2s.
Okay.
And then I subtract 1 2, and I'm left with
1.
1. Is that what you're asking?
Oh, I think so.
I just didn't write everything down. I just put down I have 2 of them, and over here, this is the 4's place, and 1 4 is equivalent to 2. Wait, this is the 1s, 2, 4, 8. This is the 8's place. Sorry about that. Over here is the 8's place, and 1 8 is 2 4s. Everybody follow that? But can you see where it's always going to be 2 of them, so it doesn't matter how far you move down the line in terms of place values. It's always going to be 2 of them. And 2 of these minus 1 of these leaves 1 of these. And then this one is gone, so there's nothing else to put down. Let's try number 12. What's 0 minus 1? I can't do that. So this becomes 0, and this becomes 2. 2 of this place. 2 1s. And 2 1s minus 1 1 leaves what? Then here's 0. So watch this. There's nothing to borrow here, so I come clear over here. This is the 1, 2, 4. So this is the 8's place. So I cross this out, and that gives me 2 4s. Then I cross that out and leave 1 4 and have 2 2s. Everybody follow what's going on there? This 1 8 became 2 4s. Now I've got 2 4s. I borrow 1 of them. That gives me 2 2s, and that leaves me 1 4.
Why did you need to borrow when there's a 0 underneath?
Say that again?
Why did we have to borrow when there's just a 0 underneath?
Because see, what's 0 minus 1? I can't do that. And I'd already borrowed this one to get rid of this. To say I borrowed from here, and that gave me these 2 1s. And once I borrowed that, this was a 0. So I have, oh wait, I don't have to borrow, do I? Because what's 0 minus 0? 0. Yeah, what am I doing? Making it too complicated. So now I have 0 minus 1. Now I have to borrow. So I have 2 4s minus 1 4 would be 1 4. Okay? Number 14. Multiplication. We know how to add. We know how to subtract. Now we multiply. This is easy. What's 0 times all of this? 0, 0, 0. Right? What's 1 times all of this? And 1, 0, 1. And how you move over one place, draw your line, and do what? Add. So what's the answer?
1, 0, 1, 0.
There you go. That's multiplication in binary. What do you think? Let's do another one. We're doing multiplication here. What's 1 times all of this? See, I'm just writing from right to left. Isn't that the way you do it when you're doing your regular kind of multiplication? Then what's 1 times all of this? 1. 1, 0, 1. Move over. What's 1 times all of this? 1, 1, 0, 1. Then what do I do? Add all that together. And I get 1. And what's 1 and 1? So, I'm going to change back to black. So this is 1. 1 and 1 is 2. That's 0. Carry the 1. 1 and 1 and 1 is 3. That's 1 and carry the 1.
Were you quoting the Beatles?
What?
What?
What did I do?
Nothing. Never mind.
It doesn't look like a 1, does it? 1 and 1 and 1 is 3. That's 1. Carry a 1. 1 and 1 is 2. That's 0. Carry a 1. 1 and 1 is 2. That's 0 and 1. And that's the answer to 1011 times 111. So there's only one more operation to learn. Add, subtract, multiply, and do what? Divide. So we're going to divide this number by this number. Well, I've got two places here, so I put a 1 up here and then put 1, 1 underneath, right? And draw a line and do what? Don't we subtract? So that's 0 and 0. Agreed? Then what do we do next? Drop the 0. What's 1, 1 into 0, 0, 0? That'd be 0. Everybody follow that? Now, do we need to write zeros out there and subtract and get 0? In other words, do we need to do this? 0, 0, 0. Draw a line, subtract, and we get 0, 0, 0. And then we bring down the other one. You see why it's not necessary to do that, but I'll do it anyway just to show you the total thinking process. So now, what's 1, 1 divided into 1? Isn't this too big? So what do we put up here? 0 again. And what's the remainder? 1. You like that? You don't like that?
Would you need to put the 2 in there?
Oh, thank you. 1, 1, 0 to the base 2, remainder 1. Thank you. Let's do number 22. Any questions? Let's do another one. 1 times 1 times 1, 1. And that's 0, 0. I bring down the 0. And what's 1, 1 into 0? 0. So I take 0 times that. Draw the line, subtract. Bring down another 1. What's 1, 1 into that? 0. Bring down another 1. Okay, so now I'll do it again. So that's 0, 0, 0, 0, subtract 0, 0, 0, 1. Bring down the other one. What's 1, 1 divided into 1, 1? 1. And that's your answer. There's no remainder. Draw a line, subtract, and you get 0 remainder. Does that make sense? So, does addition make sense? Does subtraction make sense? Does multiplication make sense? Does division make sense? Whoa, what's this? Let's do one more division problem. We're dividing by all three of those. So I put a 1 over here. Draw a line, subtract. Bring down the next number. What's 111 into 0, 0? Bring down a row of zeros. Subtract. I get row of zeros. Bring down another one. What's 111 into this? 0. Bring down a row of zeros. Subtract. Bring down another one. What's 111 into 11? 0. Another row of zeros. Subtract. 1, 1. Bring down the last one. What's 111 into 111? 1. 1, 1, 1. Draw a line, subtract, no remainder. Is that beautiful? That should be in the Nelson Atkins Museum of Art. Is that it? Number 26. There's no 26, is there? Oh, maybe it's on the next page. No, there is no 26. Oh. I just did it because I wanted to make a different kind of problem. I took 24 and changed it just a little bit to show you one more problem. 1 times this would be 1, 1, 0. Draw a line, subtract the 1. Everybody follow that? Subtract, and I have 1 left over. Then what do I do? Then I bring down the 0. What's this into this? 0. 0, 0. Subtract. 0. No, that's not 0, 0. That's 1, 0. And then I bring down a 1. So now I have 1, 0, 1. Can I do 1, 1, 0 into 1, 0, 1? No, so I put down another 0 and put 0, 0, 0, and I have 1, 0, 1, and I bring down another 1. Can I subtract this from this? So I put 1 and put this down here. Subtract 1, 0, and what is this? Borrow from this, and that gives me 2 of these. 2 minus 1 is 1. Then I bring down the last one. Can I divide this into this? Yes, 1 time. And 1, 1, 0. And 1, 0, 1. So what's my remainder? 1, 0, 1. And what number in decimal is 110? One. 110 would be 14, right? 13. No, 14. Wait, up here. 14, 12. So that would be what? 6. So in decimal, this would be, I'll change back to black. This would be 6. And what's 101? Ones, twos, fours, that's 5. Everybody see what's going on? And sometimes translating it back to decimals helps you see what's happening so you don't get so frustrated with it. Well, can you believe that? That's all there is to adding, subtracting, multiplying, and dividing in binary. Stop when you get to problem 23. And wouldn't you know, right here when you have all this work to do, right before the break, you have all this extra time to get it done. Now, this would be a good time for some of you to say, I'm going to come up to the front table and get my exam and correct it from either chapter 3, chapter 2, or chapter 1. I have them all in my little satchel there. I guess what I need to do is turn this off so I can turn off the record.